Hi, students. So if you want to make something, what is your first step? If you want something, just tell me. Okay, just name it. So name it is important. If you want to something, so you name it, you'll get it. Okay. So this is much like a naming. So if you want a program which is called the foobar, so you just name it. How to do that? Compiling the object files using the C++ compiler, G++ here. And C flags is like this. And how to get these objects? Just name it. This object is compiled using foo.cpp with foo.h. How about bar.o? You are compiling, just name it bar.o. Is derived from bar.cpp and bar.h. So what we learned today is declare first if you want to make it. So declaring means that it is just name it. It is just like naming, name it. And the difference of declaration and definitions will be explained briefly, and how to use Makefile will be exemplified. So here is a girl group, but the important one is that they are saying that tell me what you want. Tell me what you want. That is very kind saying that tell me what you want. Then I will try to fulfill it. Can you describe it in detail? So just name it and describe it. So even if you have a genie, you have to tell him something. Tell her. In this case, tell her something. So do you remember how to write functions? How to write? You have to ask 3 questions. Ask it. So if you have Genie, then Genie is asking to you. So you are asking to yourself, what does the function do? And then you name it. What does it need? You name the arguments. And what does it return? You are deciding the return value, return type, or return value. So how about writing a class? You have to ask it, okay? What is it for? So it is for the name. And what does it need to support as an operations? It is for the methods. And what does it store? What does it need? So it is for the fields. So this name and method, fields, and methods are specified here as a class diagram. Okay, so this is called design sometimes, but and in any case, you want to something, but then you name it. So it is about the declaration. So protocol and action. Protocol of a function. Protocol is some procedures how to do that. And action is some actual thing to obey the protocol. That is somewhat like a prototype is a declaration. Prototype of a function. My function add is accepting two integer parameters a and b, and then returning the result. This is called a declaration. which is a prototype. And definition may be somewhere else. Int add, int A and int B with body return A plus B. It can be located somewhere else. Up to now, we have used a single file for this, but you may use as a header, and you may use this as a source. So the external declaration is also the definition of a variable will be somewhere else, and the declaration will be of that variable inside of my inside somewhere else. So declare it first if you want to make it. So declare a class before defining it. The concept is much like a type declaration. The declaration makes the name visible, and then you just supply the details. So this is the magic of including library classes. You are include string, you know to use a string, but actually the string class is implemented somewhere else. It is just like header. It only contains a declaration. So when you compile it, it does need the header only. And then when you build it, you want to build it, it is linked using with other library files. So once you declare, you have it. So I have declared here. So actually this is not a declaration. So if I want to declare it here, you may like this, you may add like this. But if I want to add it somewhere, then you may want to inline point dot dot point with two integer variables x and y, and then they are initializing the fields x with x, underscore x with x, underscore y with y, and the body can be empty. Okay, so up to here, the left side is called a declaration, and the right hand side is called a definition. And declarations may be stored point.h, and definition may be reside in the point.cpp. Okay, that is the story of a declaration and definition. So you know that you can find the point.h. It is declaring public. So it is good to make this as a private. Get x, get y, set x, set y, and print. Those things are declared. And include ostream is included because I need std ostream here. You know that you need ostream here. Okay. So it is good. And how about pointer cpp? Then get x, get y, set x, set y, print is declared here, is defined here. So all the functions are defined. So you may, since this is a function, you can use you can use them as a function style like this. So any way we'll do that. Okay. And for the declaration of it, you are including point.h. Okay. And how about the main file, main function? You know, the main.cpp has a point, set x, set y, and print. Okay. So let me just compile those. You can compile them. G++-c point.cpp is compiling it only. So the flag -c is showing that just compile it. So you can check the time it is created. The point.o is just created today, okay? But other files is not created now. So you can just check it, g++ minus c main.cpp. It is compiling it. And then you can build up g++ main.o, point.o. Then it will generate a.exe. So let's just check it. a.exe generated just now. So just you can execute it. 3.5 we've executed. So these several steps, compiling source file, compiling another source file, compiling another source file, is too tedious. So it is very good to make a makefile. The program structure, declaration is in the header file, definition in the source file. For using point is another source file. So the point.h is included several times, okay? But in some cases, if you had another file which is called, how about 2D point? 2D point. TD point, the CPP may include point.h, and TD point.h may include, sorry, I'll make it more specifically. Delete this. How about TD point, tdpent.h is another header file, but it may have a sharp include with quote point.h. And then the td point.h may be included here. tdpent.h. Then you know that point.h is included directly in main.cpp, and it is indirectly included via td point.h. So this is a problem because your class declaration will be residing double. Okay, that is a problem. So let me show that situation using your point.h. So just make it as a td point point.h. It is just include point.h, and it is just declaring variable x 12. Okay. So in your main.cpp, you want to include tdpent.h. You know to use x. So cout x and the line. Okay. Then this is an error because you will have two declarations of a point. So let me just check it. G++ minus c main.cpp. This is an error. This is another error for end line, the CPP. std cout std end line g++ minus c main.cpp. So you know that class point is redefined. So in order to prevent this kind of multiple inclusion, you have to wrap the header file. It is safe to wrap the header file much like this. If not defined. So this can be arbitrary, but generally underscore underscore point dot h. Then you may define point underscore h. So this is wrapped up your declaration, and then if your main is including point.h first, it is defining it, okay, and it is really included. But on your second trial, since it is already defined, it is not included in double. So after saving this, you can check it, G++ C main.cpp. This is not a problem. Okay. So for the in order to prevent multiple inclusion, it is safe to add here, if not defined, underscore underscore of it is actually dependent on the file name, point h. So this name may be arbitrary, but define and if is wrapping up as a closing. So this will prevent multiple inclusion of point.h or any header file here. So in any way, you are making several files. So you want to using a make file reflecting the dependency. The arrows of the previous picture show the dependencies among file because your point.cpp needs point.h, your main.cpp needs main.h. Okay, so those dependencies can be specified using makefile. So your target all is dependent of the object files, so you can make it. This is an automatic rule. So the automatic rule is generating from arbitrary C, your arbitrary.h. So as you know, the point.o is created point.c. Main.o is created from main.c. pp. See pp here. So in that case, you can make this kind of makefile. So let's take a look from your laboratory here. So in your makefile, cpp point.h. Okay, and then you want to edit, right? Edit, what was it? In the cpp. Edit point.h is not needed anymore. It is just for exemplifying. After that, you can make it. Make. Okay. So your point is available and it is done. So after this making, you just main.cpp is just change it a little bit. Then if it is modified some part of your code, then make it will compile only the changed one. So you know that main.o is changed, point.cpp is not changed. So the main, since the main.cpp is changed, it is compiled only main, not point.cpp. Okay. So this problem is using string. Using strings, you can use a string as a string. So you know that cout is an output stream, but you can use a string as a cout. So that is called a string. So cout is a stream, output stream. If you have a string buff, then that can be a string. So you may create another string based on buff that is called a string stream. So you have to include stream. In the old Indonesian case, str stream was the header file, but it is renamed stream to use them. So in this case, you are using ostream stream, which is called output string stream as a buffer. You have several words, hello, C++, word, and then you'd like to print a bar to the buffer, and you are printing every verse, hello, C++ word, using set with word into the buffer. So you have a using buffer, and you are filling minus minus and set with. This will be explained later, but it is actually same with this, same to this. And buff fill previous, so it is a reset of filling characters, and you will access actual string from your string stream. So the note way to print horizontal line, the first one is hard-coded, but the second one is using the fill method to change the way to fill the spaces. So rather than this complicated one, you want to right here. So you may want to that, if it is for writing, you may want to see out. Okay, so it is printing a bar, every word with an end line, and printing another bar. Okay, so saving this, make OS string, and you're executing OS string. It seems good. Okay, but what if you want to print them twice? Then there's two ways. The first way is making a function to encapsulating all the things. Okay, the first way is making a function which is called print, encapsulating all the details here. 1, 2, 3, 4, 5 lines. And that print will be called twice. Print. This is one way. Make OS string, that's the PP. Make OS string, sorry. This is a problem. Okay, so let's just take a look again. So actually, this is not used. This is not used. Okay. Make OS. Words. So this is more complicated. Okay, so let's just words should be moved to here. Then OS string will print them twice. Okay, but this is not a good way for this, because there's another way to do is that you are just 1, 2, 3, 4 lines is moved to here again instead of print, and print is deleted, and you'd like to use buff instead, which is a string buff, and see out buff the string will be printed twice. Okay, So all the details of printing is encapsulated in a single output stream, and it is printed twice. Make ostream good os. Okay, so it is good. So how about the this one? Field character is that if you want to change this into 7, so how about 5? 5 is good. So if you want to change this into 7, okay, so let's make it 7, then make all stream and printing them all stream. So can you see it is misaligned? Okay, so rather than that, you may want to make a set width somewhere here. So you want to set width with 7. Actually, it is for width, and printing an empty string and print the closing this. Okay, in the same way, you want to do that in the previous one. Okay, but the problem is that make ostream the actually minus for the bar is disappeared. So how to fill up with those spaces with different characters? You can do that with buff fill. Actually, to arbitrary stream, you can do that. So you can use buff fill with minus character. Okay, but with this, all the printed one will be filled up with buff. Okay, so that is another problem. So write it to make ostream current directory ostream. So can you see there's the minuses on the hello, minus, 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 a C++, minus, minus word. It seems not good. Okay, so after the field character, you don't like to make it back up to the previous one. So how can I store the previous? Can do that with the character. Previous ball field will return the previous one. The same way, you can do the similar thing. Copy this with the previous, and it is set field, buff field previous. Okay, with this complex setting, you can do that. Make ostream seems good. Okay, and you can change them arbitrarily. Integer width, maybe 10, and set width with width, set width with the same width, okay. Ostream is set as 10 seamlessly. Okay, that is why I exemplified a complex mechanism for buff fill and resetting it. Okay. Any questions up here? So note the way to print horizontal lines. The first one is hard-coded. This is hard-coded. But the second one is using field method to change the way field spaces. Though the second way needs more code lines, it is more flexible than the first one. Any other questions? 수고하셨습니다.